In this video, I want to go through a CFA Level 1 exam style question devoted to the computation of the money-weighted rate of return, the MWR, as well as the time-weighted rate of return, the TWR, and their application to judging performance, especially of portfolio managers. So if this is something you want to get right in the exam, do keep watching and let's get solving. So this is the question that I want us to go through. At the beginning of the year, a portfolio manager purchases one share of stock for €150. At the end of the year, the manager purchases another share for 170 and holds both shares until the end of the second year when she sells them for 190 each. The stock pays a dividend of 10 per share at the end of each year, which the manager does not reinvest. The money-weighted and time-weighted rates of return on the investment are closest to, and we've got options for both. Right, let's start obviously with the first one. That's going to be the MWR, which stands for money-weighted rate of return. And this is really, really easy to compute if you're asked about it. It's just synonymous with the IRR, internal rate of return of the project. So this is something I've already done questions on. You should be able to compute it using the, for example, the cash flow worksheet. So what is this going to be on a timeline? Well, let's have the relevant inputs because you're going to have the cash. The trick here is to get the cash flows right. Okay. At time 0, so over here, what happens is we've got an outflow of 150, and that's going to be our sort of CF0, cash flow 0, in terms of the calculator inputs into the cash flow worksheet. Now, on the next date, that's time 1, there are two things which happen because we're told the manager, she purchases another another share for 170, but the stock also pays a dividend of 10 per share at the end of each year. So what I'm going to assume is that the share she purchased over here now pays a single dividend equal to plus 10. She also makes an outflow for the purchase of the second share. So on a net basis, this cash flow at time 1, C01, as it is called on your calculator, is going to be a negative 160 net. And then we've got also time 2, when she, I guess, receives the dividend from both shares. She's holding the first share from here, the second share from here. So over here, she gets a positive 10 times 2. So that's a 20. And she also sells positive for 190 both shares, well, each one of the two shares. So what we've essentially got is 10 and 190 per share. That's 200 times 2. So the C02 cash flow is overall a positive 400, isn't it? And we now need to simply take this, plug it into the cash flow worksheet on the calculator, something you should be absolutely comfortable with by now. Let's get the calculator and do it. Okay, let's head into the cash flow worksheet on the calculator, clear any any inputs which may be sitting in that worksheet from previous questions, and let's get these cash flows in. So it's a 150 negative for CF0, then press the down arrow, 160 negative, follow this up with enter to confirm this input, and the final one at time 2, is a positive 400, press enter. Bingo, that's it. Now, don't bother computing NPV. We don't have a discount rate, and this is not what the question is about. It's about computing the IRR. So head straight to the IRR function, press compute, and as you can see, it's telling me that the relevant return or rate of return is 18.45, and that's the money-weighted rate of return. As simple as that. You just need to get the cash flows right. How about the second one? So that's the time-weighted return or rate of return. Well, this one, what it will get you to do is think in a slightly different way. what you're going to have to do is break this whole investment down into the relevant periods or investment periods. And first of all, think about holding period returns, sorry, HPRs, which stands for holding period return for period 1 and then period 2, irrespective of how much money was actually invested in the relevant period. Okay, I know this may seem abstract at the moment, but let me tell you what I mean. So if you consider the first year, so from time 0 to time 1, let's call this holding period return 1, as in the first year. What happened was we invested a certain amount of money, so we bought the first share for a price, let's call this price 0, and then by the end of the first year, that share generated a dividend at time 1, but also the share was worth P1, whatever was the price at that point. Okay. Now, I know we didn't sell that first share, but this is not about cash flows. This is about looking at how the share changed its value, or the investment changed its value, irrespective of whether we sold it or not. So holding period return for time 1 for the first year is going to simply be the comparison of P1, whatever the share is worth at the end of or the investment is worth at the end of the year, the first year, plus D1, the dividend return it generated, minus P0, so to get an idea of the growth, divided by P0. And that's a very simple generic holding period return formula. Now, in the context of that first year, what is this giving us? Let's input the relevant data. So I've got a P0 equal to what? 150. That was the price initially paid. We've got a dividend at the end of the first year of 10. And obviously, we've got a P1, the price of a single share for which we actually bought the second one, but that doesn't really matter. The shares were worth 170 at the end of the first year. So if I input this into my calculation, I'm going to get 170 plus 10 minus 150 divided by 150. So 170 plus 10 minus 150 divided by 150. Okay, in the first year, the relevant return was 0.2 or 20%. Good. What about the second period in this story? Well, let's head over here. So let's call this holding period return 2. And this is obviously going to repeat the same pattern, except for the fact that we now have, instead of P1, we're going to have P2. So this is going to be the price at the end of the second year plus the dividend. But from a, you can think about it from a single share. It doesn't really matter how many instruments you've got. It will not really matter that much. So minus whatever P1 was divided by P1. And as I said, I can do this on the basis of 2 shares, which we're at this moment holding, or on the basis of a single share. But whatever we do with 2 shares is just going to be double whatever we do with a single one. So P2 over here was already 190, D2 was 10, and P1 was obviously 170 because it's the same value that we had over here. Now, taking the calculator, inputting this, 190 plus 10 minus 170, divide by 170. This is a result of 17.65% or 0.175. Okay, so these are just the holding period returns. In order now to turn this into a time-weighted return, we've got to, do a bit of an additional computation, right? Let me write this down over here. 1 plus the holding period return from time 1 times 1 plus holding period return from time 2 is equal to 1 plus the time-weighted return for the entire investment horizon squared. Now, if we had more than one period, for example, 3 years, this would be cubed because we would have another component here on the left-hand side. So squared because we've got 2 years, or number of years in this scenario. Okay, so 1.20 for 1 plus HPR 1, because HPR 1 was 0.2, times 1.1765 equals, 1 plus TWR raised to the power of 2. And you can probably see where this is heading. TWR equals the square root of whatever we've got here, 120 times 1.1765 minus 1. Let's take the calculator and do this. Let me just recall or remind you that performing this computation on the calculator is the same as taking whatever we've got there and raising to the power of 1 over 2. So taking the square root is synonymous with this, which is probably going to help you on the calculator potentially, although there is a key where you've got the square root of x, so maybe that's not such a help. So 1.2 times 1.1765, press the equals key. Now square root this and deduct 1. Okay, I can see that the TWR here is the time-weighted return is 18.82%. Now, how do you interpret this? If you invest $1 into this portfolio, it would grow, the portfolio would grow by 20% in the first year, and then 17.65% in the second year, and that's synonymous with an average rate of growth of 18.82. So if this portfolio grew by 18.82 in the first year and then 18.82 in the second year, you would get to the same end value as with growth of 1.2 in the first and then 17.65% in the second year. This is the technical way to compute this. You can, definitely explore the curriculum and some further questions which I'll be recording to actually get to the logic of what this rate means. However, what I want you to now appreciate is the fact that these are going to be used for portfolio performance assessment. And the thing to realize about the money-weighted return is that it's a suitable way of measuring somebody's performance if they've got control over the cash flows, in and outflows from or to the fund. Because under the IRR, which is the same as MWR, money-weighted return, it will matter when you had more money invested. Was it here or here? Now, the problem is this fund manager delivered better performance in the first year than the second, because they delivered 20%, over here in the first year, and then only 17.65% in the second year. However, they had more money in the second year, which kind of weighs on the on this performance measure because it's money weighted, meaning the more money you've got invested, the higher impact that has on your overall performance as measured by the MWR. The thing about time-weighted return is that it's completely independent of how much money was invested at a specific time. So it doesn't matter if you were playing with twice the money or 3 times the money in a certain period than in another. We just care about your performance independent of the scale of investing. And the time-weighted rate of return is therefore considered to be better if you are assessing the performance of a portfolio manager who doesn't ultimately exercise complete control over the timing of the inflows into and out of the fund, which is going to be the case with many portfolio managers in an open-ended setting. Anyway, going back to the question, this was a question which only asked us to do the computations without necessarily the theory behind it. But if we check this against the appropriate solutions, I'll be able to see that the correct answer is B.